We have reached the end of our discussion on the various memory areas which are available inside of the JVM. We have discussed in detail about the method area, we have discussed in detail about the heap area and stack area in our previous sessions. In this session, we have discussed in detail about PC registers and native method stack. So, we'll be concluding this topic with a summary of whatever we have learned till now. Okay. So, and also an example which would make our lives easier and would help us to retain the knowledge which we have gathered throughout all these sessions. Okay, so let's get started. So for every JVM we have one method area and one heap area allocated to it, irrespective of whether the JVM is running a multi-threaded program or a single threaded program. If it is running a multi-threaded program, this method area and heap area will be the same for all the threads. That is, say for instance, we have a multi-threaded program where we have n number of threads, T1, T2, T3 up till Tn. Therefore, all these threads are allowed to access the method area and all these threads will be able to access the heap area also, which makes the method area and the heap area not thread safe. Okay, therefore, since this method area and heap area can be accessed by all the threads which are which have been created while execution of the program or during runtime, therefore method area and heap area are actually not thread safe. Moving on to the next point, we have stack area, PC registers and native method stack 1 for each and every thread that are getting created inside of the program. That is, here we have, say for instance, in a program we have say 3 threads, T1, T2 and T3. So for T1 we will have a separate stack area, we'll have a separate native method stack and we'll have a separate program counter register. I am using short forms. I guess you will be able to recognize these. Stack area. Similarly for T2 we will have another set of stack area, native method stack and program counter register. And for T3 we will have another set of stack area, PC registers, native method stacks and PC registers. Okay. So these threads T1, T2 and T3 are allowed to access its own set of stack area, native method stack and PC registers. They cannot access the native method stack, stack area and the PC registers of thread 2, which makes these memory areas thread safe. Therefore, we can conclude that the native method stacks, stack area or the program counter registers, these are actually thread safe. That is, only one thread can execute these memory areas at a time. And these memory areas are dynamically created during the runtime of the program. That is, when a thread is created. Say for instance, thread T1 is created. So when this thread T1 is created, separate memory areas for the stack area, native method stack and program counter register will be created. Then then when the thread T2 is created, then at that time the stack area, native method stack and PC register for corresponding to the thread T2 will be created. So these memory areas won't be allocated earlier. It will be created during the runtime of the program as per the number of threads that are getting created. Okay. Then moving on to the next point, we have already discussed this point previously in the method area while we were discussing about the method area. That is, the static variables will be stored in the method area. Okay, and it will be a bit clearer after I covered this example also. Okay, so don't worry if it confuses you right now. Then we have instance variables that will be stored inside of the heap area. Instance variables are the class's member variables, and we also know that let me write another point which is also very important. All objects are stored inside of the heap area. Right. So how this point related to this one? So we can make object of a class, right? And a class contains member variables or instance variables. So as I mentioned in this point that all the objects will be stored inside of the heap area. Therefore, this heap area is also responsible for maintaining the instance variables of that object. So in this way, both these points are actually related, which will be like further more clear after this example. And then we have local variables which will be stored inside of the stack area. By local variables we mean like which are present inside of a block, variables which have been defined inside of a block, and the scope of that variable is that particular block only. So in that case, the variables are considered as local variables, and it will be like stored inside of the stack area or the runtime stack area. We have also discussed this in our previous session while discussing about the stack area in detail. Okay, so let's like look into the example, and it will be a bit more clearer from this example. Everything will be like more clear from this example. So in this example we can see that we have a class test, and after that as a member variable we have student s1, right? We have another static variable student s2. After that we have a local block, we have a block public static void main, and inside this block we have test t and student s3, which are local to this block. Okay, so how will JVM organize everything inside its various memory areas? Let's check it out. So say for instance we have a method area like this, method area. This is our method area. Then we have our heap area. This is our heap area. No, they won't intersect. Sorry for the mistake. Then we have the heap area. And then we have the stack area. Alright. This is our stack area or the runtime stack. So one runtime stack will be there for each thread. Since this program is a single threaded program, therefore we have just one runtime stack present for this program. Okay, so let's now look into the intricacies of how these are actually managed inside of the various memory areas of the JVM. So we have this student s1 object, student s1 member variable. So member variable will be created while after creation of the object. So we won't be storing it right now. Then after this we have static student s2. So static, as we know that static variables are responsible, like the method area is responsible for storing of the static variables. So static student s2 will be present inside of the method area. So we have s2 inside of the method area. What is the value of s2? It's an object, new student. Where are we supposed to store objects? We are supposed to, according to the last point which I mentioned, we are supposed to store object inside of the heap area. Therefore, we will have a student object defined inside of the heap area. Student class object. And this student object will be pointed by s2 from the method area. Okay. Now let's move on to the local block. Here inside of the local block we have test t equals to new test. That is, an object of this test class is created. Therefore, let's check it out. So since test t is a local variable, it is supposed to store inside of the runtime stack area. Therefore, we will store t inside the runtime stack. Now The value of this test is object type, that is new test. So as we know that objects are stored inside of the heap area, therefore test object is created inside of the heap area, right? And this t will be actually pointing to this method heap area's test object. That is, it is storing the memory reference of this heap area test object. Similarly, the method area will also store the memory reference of the heap area student object. And as we discussed earlier, that the object, like the heap area, is also responsible for storing of the instance variables. So we have an instance variable s1, student s1, for this test object. So this s1 will be there inside of the test object. And what will it point to? It will again point to a new student object. So this new student object will be created here inside of the heap area, as we know that the heap area maintains all the objects. The student object is created inside of the heap area for this s1, and this s1 will be pointing to this student object. Alright, so up till this we have covered. This one is done, this one is done, this one is done. So there is another student s3 equals to new student instruction which is present inside of the local block, that is the void main block. So as we know that local variables will be stored inside of the stack area, student s3 is a local variable which is actually present inside of this scope. It is not accessible globally, so therefore it will be put inside of this stack area s3. And as we know that new student, that is it's creating an object of student class. All objects are responsible, that is the heap area is responsible for maintaining objects. Therefore student object is again created and stored inside of the heap area, and this s3 from the stack area will be pointing to this student object. Alright, so I hope it's clear, the memory organization, how JVM actually stores everything inside of its memory structure. Everything is clear after this session. If you have any question, let me know in the comments. So thank you for your time. We'll be covering a different topic in our next session. Okay.